Woo! Hello, it's Mr. Rose. In the background are a bunch of 9th graders, and the real teacher is at Wallops, and I am the fake teacher. Here's what we are doing. We are pushing ahead with our unit on data analysis. It's called data analysis. That implies that we're like analyzing data. But data means you've like collected something from the real world. But we have not done that yet, this entire unit. All the functions from this whole unit so far are fake. And by fake, I mean the data was fake, which is to say it wasn't data at all. We just took a function and we just like plugged in, like, right, the teacher behind the scenes just like plugged in a couple numbers and got the y values out. So rephrase this another way, what I mean by that is, for all the problems you did so far, all the homework, all the quiz you just took, every time the answer was like exact, right? Like there was some function which exactly fit all the points. Can you nod if you're like, yeah, I get it? And so it was just a matter of like figuring out what that function was. But in the real messy world, things are not perfect. And you have like measuring tools, and those tools are not perfect, and people mess up. Plus like certain things like, you know, the weather, there's just some randomness built into it. And so you should not expect, if you're doing like science, for there to be like a curve that exactly goes through all your data points. Are you with me? Yeah. So the whole value in doing all of this is to come up with like a curve which will fit the data like best, so that we may make predictions and interpolations and extrapolations and stuff like that. Okay, so for starters, we will do the most basic kind of function, which is linear functions. So what I have given you are 4 points. Please plot these 4 points right now. I shall also do so. Alright, those are my 4 points. Alright, now, oh, I should say that this is still fake data, because these are just obviously just some 4 fake whole numbers that I just picked out of nowhere. I did not collect any, these numbers were not collected with any kinds of tools or anything. But, please note that while these points are vaguely linear in a kind of sense, they are certainly not actually collinear. Agreed? Okay, so the goal is to come up with a linear model. And a model of a set of data points is not a function which will go through the points exactly, but which will go through the points like somewhat. So does this look, do these points look vaguely linear enough to you that you think like a linear model might be appropriate? Say yes. Yeah. Good. All right, so the goal of today is to find the line of best fit. Is this even something that you did in like 7th grade or something like that? I feel like you should hopefully have heard of the phrase line of best fit at some point in your life until now. And if you haven't, well, I'll tell you what it is. It's a line which fits the points best. Best can mean a lot of different things. How, if I was a really good 7th grade student, how might I find the line of best fit?
Line reg on the calculator.
Oh, calculator.
Excel. You draw a line through it.
Yeah, good. You take your ruler and you just kind of jiggle it until it looks like pretty good. And then you just like draw a line. It's like actually like not so bad, right? Like it's not so bad, right? What you would do if you got that is you would have a line now. And now what you could do with that line is plug other numbers in. And when you plug other numbers in, you would get, you could get like estimates for what, you know, like f of 7 is, or f of 22, or f of like 1 or something like that. Follow? Okay. So let's try to do something a little bit more precise than jiggle your ruler until it looks good. So step 1. A linear model is being proposed. And that linear model is this one right here. Y hat equals 0.6x plus 14. Okay, please graph that right now. It's going to look way better on your paper than mine because you have like tick marks and stuff. But I'm going to try to do this. 19. And that's like 3/5, so up 3/5 or something. Otherwise known as up 6/10. I don't know. Am I even like close? I'm like kind of close, right?
Yeah.
Yeah. Good. All right. But I think if this guy is doing it right, then this point 1925 should actually be like a little below the line. Is that what you're getting? Everyone else? Okay, all right, good. Woo! All right, notice how this line is pretty good. And by pretty good, it seems to like kind of go through roughly the points. All right, how good is it? Well, to see how good this line is, we can measure by how much is this line off from the true values. The true values being the actual data, but except it's fake data. Okay, so let's measure how much it's off by. I will define a residual. So a residual is, for any given x value, y minus y hat. It is and y hat is the predicted y value based on our model, and y is the actual y value. For example, what is the predicted y value for x equals 6? Well, if I just plug 6 into the model, I get, what do I get? 17.6. What am I doing? Oh yeah, 17.6. Good job, yeah, that was not that hard. So 6 comma 17.6. In other words, my model predicts that the answer should be 17.6, but the actual answer is 19. Thus, I have a residual, and that residual, y minus y hat, is in this case just like 1.4. Cool, cool? Oh, okay, next. Plug in 11, what do you get? You get 20.6, right? Which means, oh, no, my picture's looking pretty good. Which means that my residual here is negative 0.6, right? Because it's y minus y hat. Do you agree? Let the video note that there are murmurs of agreement coming from the background. Okay, good. How about 16? What do you get 16? Now our numbers are getting pretty big, right? 16 times 6 is like 196. 23.6? Wait, is that true? Wait, hold on. 16 is 60 and 36. 9.6 and 4 is 23.6. I think that guy's right. So if this is 16 times 23.6, then what is y minus y hat? 1.4. And finally, if you plug in 19, you get times 6. That's like almost 120, but not quite 114. So that's 11.4. So that's 25.4. Good. So 25.4. Good. So there, my residual would be negative. No, it would be yeah, it would be negative 0.4. My residual. All right. So. Once you get this concept of a residual, would anyone like to speculate about what might be considered the line of best fit? Yeah?
When the sum of all residuals is the smallest?
That is an excellent answer. He says that, look man, if the goal is to have the line which is like best, then let's judge best by how big the residuals are. It seems reasonable to make the residuals as small as possible. And since there's a bunch of residuals, you could just add up all the residuals and see which is the smallest. All right, does that sound fairly reasonable? It sounds fairly reasonable to me. Unfortunately, that's not what people do for a couple of different reasons. What's one reason why that might be bad? Maybe, well, should we let this guy argue with his own self? What's one reason why that might be bad?
Some values are negative and will cancel.
That's right. It is useful to care about our residuals being sometimes positive and sometimes negative. And if you had them all canceling each other, then you might want that. What's a solution around that? Take the absolute values of all the residuals. So a second, even more reasonable thing to do would be to take the absolute values of all the residuals, take the sum of all those, and call it the best line when the sum of the absolute values of the residuals is the smallest. Okay, that is a good idea, but that's also not what we do. What we instead do is to take the sums of the squares of the residuals. Y squares. Well, one thing is I don't have a simple answer for you. I think the actual answer is like somewhat bizarre and will disappoint you when you finally learn it. But I think the one reason is it takes care of my absolute value problem, right? Because all the residuals are positive. Plus, by squaring, it sort of punishes being like off by a lot, sort of more somehow. Also, I think it just makes all the algebra easier. I think that's actually the real reason. All right, so never mind why we do this. All it is a standard, and once we adopt a standard, we now have a standard. Okay, goal. Find the line which minimizes the sums of the squares of the residuals. Well, let me see if we even understand this. So a chart is appearing here on the bottom of your paper. If you already get what to do, then do it. And if you don't get what to do, wait for me to catch up. So we have the original data, which is not actually data because it's fake. Then we have the predicted y value based on our model, and we already did these. It was 17.6. What was that one? 19.4? 20.6. Thank you. And the next one was 23.6, and the next one was 25.4. So those were the predicted y values. Now y minus y hat are the residuals. And what are the residuals? The residuals in this case would be 1.4. This residual is negative 0.6. This residual is 1.4, and this residual is negative 0.4. Everyone following? Now, finally, in this last column, take the squares of those residuals. So here you get 1.96, right? Yeah. And then here you get 0.36, and then like, what's that? 1.96. Okay, good call. Let the record show that a ninth grader just laughed at me. And when you square negative 0.4, you get 0.16. Woo! So add all those up. Has someone like done that already? Possibly with a calculator. 4.44. Woo! I have now a bright shiny number. That number is 4.44. And that number is, in words, the sum of the squares of the residuals for this line. Cool? Now, what I don't know by the end of page 1 is whether that's like good or not. Is it good? I don't know. It seems pretty good.
It's not.
Turn to the next page. Can we skip this because it's kind of boring? Can I just tell you what's going to happen?
Yeah.
A slightly more advanced linear model is being proposed. That linear model is 0.55x plus 15. And what's going to happen, we'll just edit this out of the video. By that I mean we'll edit it out of our lives and we'll pretend that it happened. When you crank out all the numbers for this top of the page, just make a prediction. It's going to be a little bit better, it turns out, than 4.44. And so the drama is building now. You were impressed by 4.44 sum of the squares of the residuals, but this line is slightly better. Now do you feel the passion? What we must do is find the line which minimizes the sum of the squares of the residuals, not by like guessing and checking, but like by some sort of like real method. Ready? Okay. I shall now teach you the method, and it's pretty hard. It's not clear that we're going to finish. So I will give you 3 points. And because this task is, was that even in frame there? Let's find out. Yeah, it was. Woo! All right. Now, let's take these 3 points that are on the bottom of page 2, or middle of page 2. 3, 1, 5, 6, 7, 8. These 3 points are vaguely linear, but they're not actually collinear, so we need to come up with a model. So let the model be y hat equals mx plus b. Does everyone understand our overall goal? Our overall goal is, it says it right there, find the m and the b such that the sum of the squares of the residuals will be as small as possible. Ready? Sounds hard. It is hard. All right, what we will now do is go to the next page, and we will compute the sum of the squares of the residuals. But we will do it like in general for not knowing what m and b are. So here we have 3, 1, 5, 6, 7, 8. What is y hat? For example, for the first pair of points.
3m plus b.
Yeah, it's mx plus b. So when x is 3, this is 3m plus b. Who's with me?
I'm with you.
Woo! Do we have to? I mean, that's an existential question. Let the record show that someone in the room said, do we have to? All right, good, next. How about when x is 5, what do we get? 5m plus b. Then when x is 7, we get 7m plus b. Cool? All right, so those are the outputs that our linear model predicts. Now what I want is y minus y hat, which is the residual. Who's with me? What is the first residual? Well, the actual y value was 1, and the y value that was predicted was 3m plus b. So what do we get?
1 minus 3m minus b.
Yeah, 1 minus 3m plus b. So we get 1 minus 3m minus b. Not so hard. Okay, next one. Here, if 6 was predicted, but this is what actually came out, what's the residual? Cool. Question? You're good? And finally, if 7m plus b was predicted, but the actual value was 8, then the residual was 8 minus 7m minus b. All right, now comes the hard part. We must square all these residuals. Good. All right. It would be nice if we had like a cute formula for squaring a trinomial. Do you want one?
Yeah.
Sure.
Good. Let's call up the formula factory, otherwise known as personal exploration. Go. Please multiply out using the distributive property these two generic trinomials and come up with like a cute formula for yourself. Everyone understand the task?
No.
Woo! Let the record show someone is talking about Boolean algebra in the background. Oh, Piper would be so proud.
Well, this is a good one.
Alright, so it is in fact like 8. Well, am I going too fast? Someone back me up.
That's correct.
Good. Alright, so now here's what we should do. We should apply this formula. So let's go. What do you get when you square 1 minus 3m minus b?
Squared plus b squared plus c squared.
Yeah, so it's like 1.
2ab plus 2bc plus 2ac.
Yeah, that's right. That's what I got too. So then here we're going to get
9m squared. Would it be 1 minus?
no, because I like to think of it like this. It's like the 3 squares, and then it's like 2 times all the thingies. It doesn't really matter how you do it. I'm just going to do it that way. Okay, so you get 1 plus 9m squared plus b squared minus 2 times that, right? So minus 6m, but then minus this times this, so, or sorry, just this times, 2 times this, so plus 6mb, and then minus 2b. Okay, do it with the other 2. Do it with the other 2, and then
That's right, don't go ahead with the
Oh, I did want
someone keeps saying disgusting over and over again. It's important to have an emotional connection to your algebra. If disgust is what fuels you, then that's okay. Also, someone check my math, because I make mistakes a lot. Have I already made a mistake? Hold on, let's try again. This plus this squared plus this squared minus, what the hell have I done? Oh yeah, that should be 12. And now this is 64 plus.
I screwed it up. I almost got the correct answer because it was like 953. And then I got 954.
Wait, what am I doing?
It just gives everyone a 40% off on the test.
Wait, stay together. Someone back me up who's like fast and usually pretty accurate.
Wait, we add all these together?
Wait, well, do you agree with my numbers so far before I waste my mental energy adding?
That is what I got.
Good. Now we add these all up. What do we get?
Minus 178 plus 30.
Minus 178.
Okay, so, hold on. Alright, so, we are reaching a point where the mindless algebra is coming to an end and the deep thinking must begin. I now have an expression. What is this expression in words? First of all, if it's wrong, someone tell me quick.
There's supposed to be an M after 178.
Now, is it good? Now, this thing in the box represents the sum of the squares of the residuals for arbitrary line y equals mx plus b. So now we have an advanced algebra task in front of us, which is figure out, well, we are going to figure out the line of best fit as the big picture by finding the particular m and b, which make this as small as possible. But now I need to minimize this expression with respect to two different variables. We're probably going to just awkwardly run out of time right now as we begin this. Someone rotate the camera so I'm in frame. Here's what we're going to do though. We're going to take this expression and we're going to write it in two different ways. One way treating it as a quadratic in B. One way treating it as a quadratic in M. So what we're going to do right now is we're going to fix B and minimize M. And here, we're going to fix M and minimize B. Alright, what does it mean to fix B? Well, to fix B, I mean just let's pretend that B is constant for the moment. If B is constant, then this is just a quadratic in M, right? And what is that quadratic? It's 83M squared. What's the coefficient of the M term? 30B minus 178. Who's with me? Plus, what's everything else, which is just a constant? 3b squared minus 30b plus 101. Do you see why I'm grouping these all together as constants? Because I'm treating b like a constant for the moment. I'm treating m as the variable. Okay? That is kind of cool. Okay, so if you now, how do we find the minimum m? Quadratic formula, or
Factor.
complete the square, or what's the cheapy way of not having to actually complete the square because you just know things? Even better than that. What do you know about any quadratic ax squared plus bx plus c? Where is the minimum? The minimum is at the vertex, which is at x equals. Whoa, wait, a whole room full of magnet students in pre-calculus should know the answer to this. All together now, more people shout things out. Negative b over 2a, is that not a known thing? Yeah. So what should we do? We should set m to be negative 30b minus 178 over 2 times 83. That's the minimum m. Then we do it over again for the b's. Get it? Fish?
Yeah.
And then you put them both together. All right. Was that a success? Would be a lie to say yes. Did we try? It would be a lie to say no. Goodbye, Internet.